Do you know this feeling? We can look at a perspective diagram and we're sure we understand it. This is our eye level. We're looking at the end of an object here, and the angles of the horizontal lines on the side of the object angled away from us meet on the vanishing point. It makes clear sense. I can see how it applies. We have eye level. And we have perspective angles on the side that slopes away from us, which meet on the vanishing point. But do you find that mostly you're looking at scenes going, it doesn't seem to make any sense at all? There's no one line here. Is this the perspective angle? 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 What about this one here? They don't all meet anywhere. What do I do? G'day, I'm Stephen Travers. Let me explain why this happens, and it's to do with the fact that often streets curve. And hey, if you're finding my videos helpful, please hit the subscribe button now. Don't leave it, you might forget. The better my channel does, the more I can put into it. So what is happening here? We might just look at a slightly simpler example first. Here we have a Paris street, and if we look at the buildings on the left side of the road, there are some very obvious perspective angles that line up well, and if we look at where they meet, we can see, yes, they meet up on eye level in a horizontal line. And of course, eye level is above the eye level of the people in the street because this street is sloping downwards. So I'm further up the street, so I'm above their eye level. And if we look at the perspective lines on the other side of the street, we can see that they also meet at the same place, because eye level is eye level for everything in our scene, wherever it is, whatever it's doing. But what happens over here? But what happens with this building down the street? Clearly, whatever's happening with these lines is not going to meet here. The important thing to remember is that eye level is eye level, which is going to be about here. But let's just slide it along. If we look at these perspective angles, we'll take the one up the very top and we'll take the one at the bottom. So if we consider now this building, and we know that eye level stays in the same place, you'll have to take my word for it that this perspective angle below eye level and this perspective angle above eye level are going to meet quite a long way off camera. But all the perspective angles in between, all of these lines fit into that fan pattern that I talk about in other videos, where above the perspective line, each horizontal line is at an angle that gets greater and greater and greater, or if the line is below eye level, it's at an angle that gets greater and greater and greater. So the issue is not that this street, this scene is working differently, but it's that these perspective diagrams only work when the objects are aligned in a straight line to each other. And that's not the case when there's buildings coming across the end of the street at a very different angle. So we have our eye level. And we have a row of buildings all lined up on a straight street, and all the perspective angles meet at the vanishing point on eye level. And parallel to this on the other side of the road, we have another set of buildings. All the perspective angles meet at the same vanishing point on eye level. But we also have a row of buildings along a street that actually crosses the end of this street. And it has a different vanishing point. And all the buildings in a straight line on this street, all the horizontal lines on the facades, or the lines where all the windows start or end, those horizontal lines all angle with this perspective to the same vanishing point. but a vanishing point in a very, very different location to the one we're looking at. And that's the limitation of this sort of example. It's dependent on all objects being aligned parallel and in a straight line to each other, as well as the ground being totally flat. And if you want to know what happens when the ground goes uphill or downhill, I've got a video on each of those. So have a look at my perspective playlist on my YouTube channel and have a look at those if you want to see how that affects perspective. And this is what's happening here. This building here, where we only actually see the edge of it, has yet another vanishing point on our eye level that goes off to the left-hand side, which is in fact going to be even much further to the left than the vanishing point for these lines are for the right. But the eye level stays the same. And that's because this building is actually angled away from us. It's not parallel, but it's angled away from us. And a very important principle of perspective, which we don't often hear said, is that the greater the angle of the side of the object moving away from us, the closer the vanishing point's going to be. So this wall of buildings here is moving away from us at a much steeper angle than on the other side of the road. And so the vanishing point is closer to these buildings than it is to these buildings, where the angle is more shallow because we're not standing in the center of the street, which would make the angle the same. And therefore the vanishing point is further away from these buildings. Now the buildings at the end of the street, on this cross street, we're not looking at them straight on, but it's closer to straight on than for either of these walls. So the vanishing point is much further away. And if this side street actually was at right angles to the bottom of this street, then these lines would be horizontal parallel to the eye level and in fact wouldn't have a vanishing point at all. In exactly the same way, this line and this line are parallel to eye level because we're looking straight on to this side. And so the horizontal lines on this facade have no vanishing point. Of course, if we were to swivel this side slightly away from us, then it would look more like this. And because we're no longer looking at it front on, we've created a second vanishing point on the left-hand side. So because this wall is the wall where we are most looking straight onto it, though not quite, its vanishing point is going to be the furthest away of all the vanishing points. Let's look at a slightly more complex example. And if this is helping your understanding of perspective and you haven't hit subscribe yet, then do it now while I get the next example. This is a relatively flat street in the heart of Vienna, and eye level is about here. Why is this guy's head above eye level? It's as simple as he's taller than the average person. So if we look at these buildings on the left-hand side, we'll use lowest clear line above eye level. And we can see that, yes, these perspective angles all line up. But what we can also see is that clearly the perspective lines for this building don't line up. They do line up with each other on eye level, but it's a different vanishing point to our first vanishing point. And if we look at these buildings, we see that they are going to meet on the same eye level because the eye level is the same for any scene. We can also see they're going to create a vanishing point further to the right than the two that we've got. And this is the same principle we looked at before. Now these two buildings here we can see are aligned in a straight line. So their perspective angles are going to meet at the same vanishing point, and that is what happens. The other important thing to note is that because these buildings we're looking at more edge on, they're actually turned away from us more than the ones further down the street. And so this vanishing point is going to actually be the closest one. When we look at this building here, again, we see that these perspective lines do converge on eye level, but in a different vanishing point. It follows that principle that this building, where the street is now curving around back towards us, means that this wall of the building is actually a little more facing towards us than this wall on these two buildings. And therefore the vanishing point, because the angle is less, is going to be further to the right. But by the time we get to these two buildings, the curve has straightened for a while. And so these buildings are pretty much aligned in a straight line, and therefore they share the same perspective angles. And I think we can see that if this yellow eye level is continued to the right, these two perspective lines will meet on it. And because the walls on these buildings are angled more towards us, we're seeing these ones more straight on than any other walls in this scene. Therefore, the vanishing point for these buildings is going to be the furthest away of all of them. In working out a more complicated perspective scene such as this one, it's important to find eye level. And if you have trouble finding eye level, one of my most popular videos is how to find eye level. So the important thing is that we find eye level, and then we look at the street alignment to work out which buildings are actually in a straight line with the others. We can see that the two walls of these two buildings are in a straight line. We can see that these three buildings are in a straight line on the street, and that these two buildings spread the difference of the angle between this wall and this wall to create the curve that we see. On this side of the street, of course, we have a more straightforward situation. Although the street curves, once it curves away from us, we can't see those buildings. But we do have another vanishing point from the other side of the street. Just quickly, here's a final example when the street curves the other way. Here we have part of Trafalgar Square in London. Sometimes it's quickest to work out where eye level is by actually looking to see where our perspective lines meet. And so we can see that eye level is here. Now, eye level is very high because, in fact, I'm on the steps of the National Gallery, and this is a slightly zoomed in photo. And the vanishing point for this building here is right off to the right. But because this street curves away from us instead of towards us, the vanishing points do the exact opposite thing. The further away the buildings curve, each set of vanishing points moves closer and closer and closer to the buildings. If we look at this building here, and again we see that the perspective angles converge at a vanishing point on eye level, but it's a vanishing point that's moving to the left instead of moving to the right when our street curved in the opposite direction. And if we look at the very last building, again we can see the vanishing point again slides to the left as that building curves away from us at a greater angle. Hey, don't be too upset with our little perspective diagram. It holds all the principles really that we need to know. It's just that life, as always, is a little bit more complicated. But as we adjust the principles, we get the understanding we need, even for relatively complex scenes. But what I always say is don't let perspective theory stop us from carefully observing what's actually in front of us. If I were drawing this scene, I would in fact be measuring the angles with my pen. But understanding the theory of what's happening here helps me observe more quickly and more accurately, which gives me a better chance of a satisfactory drawing than if I don't really understand what's going on. So I hope this has been helpful. If it has, please leave a comment and tell me that you found it helpful. It's great to get feedback. Helps to point me in the right direction for new videos. If there's a perspective angle that I haven't dealt with in my perspective playlist, then again, leave a comment and tell me. I'm Stephen Travers. I'll see you next time. Bye.